Okay, let's look at number 8 in section 5.8. We're going to calculate the following indefinite integral. And just want you to recall this that we learned from this section. The antiderivative of 1 over the square root of 1 minus u squared is the inverse sine of u plus a constant, or the arcsine function, right? And that's because we know from calculus 1, we learned the derivative of the arcsine function was 1 over the square root of 1 minus u squared. Okay, so using that, let's evaluate this integral. First thing I would note is it looks sort of like this integral form, but not quite. And one important feature that's not there is this, the number 1, right? It has to be 1 minus u squared, not 5 minus something squared or anything else other than 1. So that 5 needs to become a 1. How do we do that? Well, you can't just subtract 4 under the radical. That's not going to work. What we're going to do actually is we're going to factor out from this expression under the radical, we're going to factor out 5. Now, how do you factor a 5 out of a 3t squared, negative 3t squared? Well, we can do it. When I factor a 5 out of the stuff, the radicand here, the stuff under the radical, of course, I'm going to leave a 1 here. I'm going to factor a 5 from a 3. That leaves 3/5, right? 5 times 3/5 is 3. So this is how I factor it out. Now, the square root of 5 times all this stuff is the square root of 5 times the square root of this stuff. That 1 over the square root of 5, I can pull outside the integral. It's a constant multiple. And I'm left with down here the square root of 1 minus 3/5 t squared. Okay, so there I have factored out that 5 from under the radical, of course, so it comes out as root 5. And notice it's in the denominator, so it's 1 over root 5. It's not equal to root 5. It's 1 over root 5. Now, look at the integral form we have, right? It's 1 minus u squared. Now, 1 minus u squared. Notice this thing, 3/5 t squared. I want that to be u squared, right? To match it up, it has to be the same thing. So that's going to have to be u squared. If I take the square root of both sides, I get u is what? The square root of 3/5. Square root of t squared is t, right? Square root of 3/5 t. And so there's my substitution right there. U is the square root of 3 over the square root of 5 t. So take the derivative of that, I just get the square root of 3/5. So du is the square root of 3/5 dt. Now I need to solve for du, so I'm going to multiply by the square root of 5/3, right? The square root of 5/3 times the square root of 3/5 is 1. So I have the square root of 5/3 du is equal to dt. So now I'm ready to change everything. The du I'm going to replace with, the dt up here, I'm going to replace with square root of 5/3 du. So there's at the top. Over the square root of 1 minus what? 3/5 t squared. That's u squared over 1 minus u squared. Don't forget our 1 over root 5 that we pulled out earlier is still there. This is a constant multiple. Can pull that out. It comes out as 1 over root 5 times the square root of 5/3. Remember, square root of 5/3 is the same as the square root of 5 over the square root of 3. And so the square root of 5s, I can divide top and bottom by square root of 5, and I just have 1 over the square root of 3 to simplify that. And the rest is in the form we need it in. Right now we're the square root of 1 over u squared, square root of 1 minus u squared in the denominator gives us the arcsine function. So there's our antiderivative. And then we're going to go back to the original variable, right? U, what was u? U was the square root of 3/5 t. Excuse me. And so that is our result. I hope this helps.